Hello, my name is Peter Pilgrim. I'm a Java champion, Java tech coach. I'm going to be speaking to you about this, Taming Complexity Functional Error Handling with Arrow.kt in November 2025. Apologies, my recording of the actual webinar actually failed, so I'm re-recording this for your pleasure. So I like to thank you for attending, and because every one of us wants to really succeed in life and code and everything. So, how do you get in touch with me, Peter Pilgrim? I have it at gmail.com. I have a website, LinkedIn, Twitter, X, Blue Sky, Mastodon, and then GitHub. And I live in Milton Keynes, Buckinghamshire, England. Yeah, contact me if you're interested in outside IR 35 contracts in, say, mid 2026, or just contact me if you want tech coaching and training 1 day, 2 days. Okay, over and out to the webinar. Beyond imperative, I guess this is for people who've been hurt by some of the functional programming intimidated ecosystems. You're here because you're a problem solver, and I wanted to show you Arrow can help your Kotlin code safer and cleaner and fun, of course. So let's go for a direct clear. A lot of people are moving from Java to Kotlin recently, and I wanted to help you achieve that clarity. So the setup, I use JDK 24 for this, Kotlin 2.2, Gradle SDK man on a macOS machine. My MacBook is pretty old by now, but I still use IntelliJ IDEA. Ultimate, I have a license, but you can still use the community edition. And I have a GitHub repo, which starts a code for this presentation. I'll present that later. So Kotlin, language design, expressiveness. Let's gloss over this. Boilerplate. Yeah, don't repeat yourself. Write everything twice. Kotlin has null safety, extension function, smart cars, and a functional style. I know Java 25 introduced project Loom, and it's got the nice println, the IO println, and a simplified main. And it's getting there with the type inference and stuff. But there's still a way to go for Java 24 to catch up with Kotlin in certain aspects. Coroutines, that's really Kotlin specific, structured concurrency. Shout out to Russell Winder, who's no longer with us, who showed me a lot of this structured concurrency in Groovy a long time ago. And Java 24 does have virtual threads, and perhaps in 2026 the Kotlin team will integrate with Project Loom and Valhalla and the rest of it. Kotlin still has nice async semantics without callbacks, suspend, and since IntelliJ, or really Google invested or got behind in the Kotlin programming language and IntelliJ way back in 2018, was it? Kotlin has seen a great rise in popularity, not surprisingly in Spring AI, Ktor, and Reactor. Yeah, so things are still happening in the Kotlin world. So the interoperability is 100% Java. You can safely mix Kotlin and Java code in the same Gradle or Maven project. So you can gradually migrate Java microservices to Kotlin, or just keep the same code bases in the same project. Kotlin compiler produces the same .class files, and so therefore there's zero lock-in. You can start with Kotlin incrementally. So Arrow, let's look at the thing that we want to talk about. It's a collection of self-contained libraries that either solve a work, item, or task that enhances the Kotlin programming language to some degree. It's more functional in nature. Latest version is 2.1.2, up to 2.2.0 October 2025. So I think I upgraded to 2.2.0. If you use Arrow version 1, you realize you need to go up and look at the migration notes and change your code base. At the time of writing, there's a fair point in November 2025. Kotlin does not support Java 25 bytecodes, but by 2026 or early next year, I think that will be solved. There are 5 Kotlin Arrow libraries: Core, FX, coroutines, optics, resilience, and software transactional memory. We're going to focus on Core here because that has the error handling, raise, either IO, and option. If you're interested, you can look at circuit breaker patterns, try and retry patterns in resilience, fault tolerance, FX coroutines, that's sophisticated concurrency and resource management. Optics, I think that is useful if you're looking at complicated data structures. You're doing extract, transform, load work, and I think that will be helpful for that situation where you've got really large data structures, and optics implies lenses. Need I say more? Let's move on to the code. So today's code, you typically have a problem that you've got Java code that throws exceptions or could throw exceptions. So here's a canonical example: a square root from a string that accepts a string or returns a double. And notice in Kotlin, the syntax is variable name, parameter name, and then type. And the type of this function here is going to return a double. And so first line, val number equals string to double. So we're converting a string to a double, and we're assigning it to an immutable variable number, hence val. So after number is assigned, then it cannot be changed or modified, and the compiler will complain. And then all we do is return the square root of this number. Simple, eh? What else do you see? Well, the first thing that experienced Kotlin and Scala people do is, hey, I can write this as a one-line string, one-line function where I simplified square root to string equals square root of string to double, and the double return type is inferred, so I don't have to add colon double here. But what else is wrong? Well, exceptions are what happen. So we know if the string is just foo or ABC, that cannot be converted to a double, so it throws there a number format exception. And then we turn a square root. It will not work for negative numbers, so your number has to be greater or equal to 0 for square root to work. So how can we improve this? So Kotlin has nullable types, and in the earlier version of the Kotlin compiler, pre 1.0, this kind of made sense. Double question mark meant, okay, I need to deal with the consequence of returning a null here, and hence the Elvis operator here. And when I convert string to double or null, you actually get the double, or if it cannot work, return a null here. And then you can also then return on an expression, or if returns an expression in Kotlin. So if number is greater than 0, then take the square root of a number, else return the null. It's kind of like a more elegant tertiary operator in C, C++, and Java. Okay, but what does Arrow do? Arrow is a library that helps with this task, and what Arrow introduces is this either string or double. and that's what it is. So the return type is an either that takes a string or a double. So on the left hand side is the convention, that's the error, and then the right hand side of the complex type is the success. So we really want a double for the program to work. So that explains that the return complex type of our evil square root function here. And notice we have a either function block. This is actually part of the domain specific language of the Arrow solution. It's an extension function that executes a functional block. Well, it's not an extension function, just a function, excuse me. And what we have inside of this is a couple of keywords that the either understand. Raise will inform the either that actually the left hand side should be filled in, and then we stop the execution then of the functional block. So it actually falls out of this functional block, and so once the left hand part, the string is filled, then we're done. Ensure is, you can think of it as an assertion, where it takes the number, if it's greater than 0, if it's ensure that the number is greater than 0, then it's fine. If it's not, then it's like an assertion, ensure, and if that we return the left hand side as an error condition, as this string here cannot calculate the square root of the negative number. And then the last part of the function block is to take the square root of the number. Phew, great, isn't it? So it is really helpful to see that we're not actually throwing exceptions, and we got this if then else complicated logic. That's the great part of Arrow. It looks really functional. It looks like declarative language, and that's the best functional way of where it's so it makes sense, it's readable and is concise, and I can read this in a git commit and say, oh, I understand what's happening here, and I approve that commit, and on to the next story as a technical leader, which is great. So let's get a diagrammatic illustration of the either. So as I said, either is a generic type, and it takes a left type and a right type. In this case, the left type is a string, which is the error condition, and the right type is the double that we actually want to work. That's the success. Okay, so let's move on to something slightly more advanced. Normally in programs, we have error values and conditions. It might be errors from the network, or it might be JSON or YAML parse errors, or errors from WorldPay. But anyway, we have a sealed interface in Kotlin. Similarly, you can do the same thing in Java with records now in Java 25. And you've got a sealed interface here with error value, and you've got some values, the invalid number, negative value. In real life, you would actually have some object parameters and stuff that would capture line numbers and context and the rest of it. So how is this helpful for us? Well, we can format the results using this either. So here's a real use of either. I'm sorry for my touchpad, it's really sensitive, where we are taking the error value and a double. This is slightly contrived, and we're returning a string. And what we are doing is taking the result, which is that either, and folding on it. And folding is a way of taking a complicated type, a more involved type, and returning a simpler type out of the thing, like the inner type, if you will. So if left, if we have a left hand side, then execute this function, which is a kind of a lambda that is a lambda that takes an error parameter, and when we pattern match on the seal type, if it's an invalid number, then we know it's an input error. If it's a negative value, then we know it's a master error, and anything else is unknown. If we have a right hand side of our complicated either type, then just do some work on the value. We're formatting the value, and that might be financial results. We might want to do more checking of the right hand side, or to get a pattern match or a search, or to get extra enriched data, for example. Slightly contrived, but you can see where we're going with this. But that's not the best thing about Arrow. Arrow allows us to use Kotlin scope functions, and I'll show you how. So we can compose. This slide is called Let's Compose, a big clue as to what I'm going to show you. So we have some functions that break up the work into constituent parts. The first function passes a number, takes a string, returns an either. Second function validates if the number is positive and returns an either. The final function calculates square root, takes a number, double, and returns an either, which is the square root of the number. That's the actual thing that we want to work on. So pass a number will raise an exception if it's not a number. Validate positive, we'll check if the number is positive or 0, return it as an either, or it will raise the exception, raise it, it will fill in the left hand side of that either. Got it? So let's move on to the next part. We want to take the result of the either and format the result, which I showed you before in the sealed interface types. So we format result. It's a function, helper function, that takes the either string or double and just returns the string, and we're doing the folding and pattern matching here. So if we have a left, we get a report on the error. If we have a right, then just format the result and return that as a string. Got it? Right. So let's reveal. So what we have is a way of composing these functions together and binding them together into one function. Let's take it slow and easy. Function, process and format, accepts a string and returns a string. It works on an either functional block here. It is inlined, so for readability. The either function block is a block that is executed on the either, and therefore there's an implicit context around this functional block. It's a lambda function, but inside of it is a secret context, but it's there. It's like the self or the this operator in object-oriented programming class languages. What we have to do is use the extension library of Arrow to bind the result, which is an either, to the context. Does that make sense? Probably doesn't. Pass number tries to pass this string and returns an either, and the result of that either is bound into the context of this either here. But if it does pass, we still get the number. And if there is a failure, then the either block short circuits and ends. So let's continue with the positive, accentuate the positive. So we get our number here because it is 1.2.3. And so the next function block is composed function is called. So we validate positive, which takes that number, that immutable value num, and passes that in to validate positive. Validate positive returns an either, and this positive number is bound. If we have a failing condition, then we get a short circuit to the end of the function. On the other hand, if it's right bounding, that is a successful result, we have then an immutable positive number at this point of the execution, which we can pass into the final function, calculate square root. And therefore, we got the positive number, we verified it, we can calculate the square root, and calculate square root returns an either. Again, we bind on that either result, to the either. Getting excited because we come to the end. When the functional block is finished, we have either an error or the success. So either a string, the error condition, or either the double, the successful result. And the let is a scoped Kotlin keyword. Think of it as also or with. It means execute this functional block here, which is actually format the results, against this object context here. So that's why we have dot let. So it's really complicated, I know. Think of either as this object, as this ball of definition. It's a context object, and then you execute the function. And if you think of it, in some languages you have a with syntax to simplify the logic, and that's what's happening here when we call the scope function let. So all we do is format result. But the brilliant thing about this, it is actually readable, and you can work out what is going on, even though the kind of it's a kind of a swan. You know the legs of the swan or the duck, or the goose in the pond, the lake. Things are happening, and it just looks so nicer. Okay, to deal with this, let me explain about the let function. So the let function is executes against a scope, and you can think of it as a scoped variable. So here I am creating a customer account, Andrew Clark, with an account number, and the let is a scope function that allows me to execute code against this customer account object in place. That's the way to explain it. And so I am taking a standing order from a gas supplier, getting the amount, and with this customer, I am doing a balance check and then performing a direct debit of the amount for the standing order. And then I'm doing an audit check. And you can see how nice this programming looks, because once you understand the details of what's going on and what Kotlin is building under the hood, it reduces the boilerplate. It takes a bit of time to understand. So there are 5 scope function in Kotlin. Let's let, run, with, apply, and also. Okay, the final piece of the puzzle, and I don't recommend this at all, is to use IOR. So IOR provides a third option, a special type of both to represent potential errors, even though you have a successful result. That's all you need to know. So I'm going to show you this advanced example, and it will probably blow your head off. But what we're doing here is slightly contrived. So we are processing data, and all we want to do is return the length of a string. But the length of the string has to be greater than 5 or equal to 5 characters here, and it has to contain the data keyword. I told you it's contrived. The main bit is we've got an IO and this combiner, because we have to combine. Let me stop it. A string plus. We need this parameter which combines the strings together. So we've got an IO of a string or an int. How do you combine the various warnings together? We need a combiner parameter, and that's what this first argument to the function IO does. And then we've got the functional block, which is the second parameter. And here, I want you to concentrate at the end of this function. If we have warnings that are not empty, we are going to assign IO both warnings to string and the length of the string, the input string. So that is step 2 here. If we don't have any warnings, then we assign a write. And what we have to do is bind again to the context, the surrounding object that we're operating on. I told you this was complicated. Okay, so finally we can demonstrate this, what IO does, and it's advanced. Yeah, you can look at the code later. To demonstrate, we build a list of string type, collection of link type, a mutable list, hi, data set, hello, data. 4 elements really of a list collection. And then we execute a for each functional block on each of these elements in the list collection. We get the traditional functional block here, like for ints and import. We process the data. We get an IOR as a result type, and then we fold. And then I've highlighted in green here. If we only have warnings, then we print warnings only. If we pattern match on success, there are no warnings, so pure success. But most of the time, probably we get warnings and a successful outcome. So we print the success with the warnings. And that's it really. That's all I'm going to show you of IOR. We don't use it that much, and because it's complicated. The executive summary. It's a quick introduction to Arrow Core. Resources, type errors. I'll put that in a slide deck and share the code repo with you. If you have any questions, you can email me on X. You can blue sky me, get me on LinkedIn. And so thanks for watching. And this is a repeat presentation. So I bid you adieu and coding. Enjoy it. Have a great day wherever you are. Thank you.